Welcome back, everyone, to another Code Meets World, and today we're going to be continuing in the bit manipulation category for the second problem, number of 1 bits. So here we're told that we need to write a function that takes a binary representation of an unsigned integer and returns the number of 1 bits that it has. This is known as the Hamming weight. Some languages, such as Java, there's no unsigned integer. I think I'm okay in Python. Yeah, I don't think I have to worry about these in Python. So let's look at some examples. It sounds pretty straightforward. So, these are huge. I think unsigned integers are 4 bytes, which is 32 bits. Yeah, we're going to be given a 4-byte unsigned integer, so 32 bits. So given one of these, we just need to return how many 1s are in it. So this one has 3, this one has 1, this one has 31. Okay, let's jump down to the whiteboard and talk about how to do this. So like I mentioned last time, I've seen some of this stuff before, and it might not be super relevant for a lot of programming interviews, but we're going to talk about it anyway. I think I remember how to do this. There are 2 different ways. One is we could simply iterate over every single value in one of these unsigned ints and just check, is it a 1? That would work, but it's not really in the spirit of the bit manipulation category that we're in. So I think there's something better we can do, which is by using the actual bit manipulation operations, the bitwise operators in Python. So let's have a think about this on a smaller scale. So let's say that we had just some small binary number. This would be the number 2, I believe, in binary. So if we wanted to count how many 1s were in this, something really interesting we could do is slide, and this is a bitwise operation, slide the bits to the right, checking that each one, is it a 1 or is it a 0? Let me show you what I mean. So we could say, is this a 1? No. So we might have a count over here. Is this a 1? No. Then we would like to ignore it. So basically like cut it off from the binary number. And there's a way to do this, and that's why I'm explaining it this way. Then we check this next one. Is that a 1? Yes. So our count is now 1. Then we could slide that one off the end of the number and check, is that a 1? No. Slide it off. Is that a 1? No. Slide it off. So we are left with 1 as our final answer. So the way we can actually do this is, let me write that number again, set this back to 0. To check the value of the rightmost bit in this number, we can use, and again, I'm going to draw this terribly probably, the AND, just a single AND, the bitwise AND, with the number 1. Because if we do this, it's going to only return if the first digit is a 1. Because if we AND 1 and 0, we're going to get 0. But if this is a 1, when we AND 1 and 1, we're going to get 1. So that's the way that we can know, is the rightmost bit a 1. So that's half of what we need to do. The other half of what we need to do is after we check, is the rightmost bit 0 or 1, we need to slide all of the bits, which is called a bit shift, to the right so that we can consider the next bit in the next iteration. So say we've checked, this is not a 1, the rightmost bit is not a 1, so now we need to slide everything to the right. We can do that in Python. I believe it's with the right arrow twice operator, which is a bit shift to the right. And in this case, we would want to do that by 1. What that does is, if we pretend that this line is the end of the bit, the end of the number. When we do this slide to the right, this 0 goes off the end of the number, which means it's just dropped. So this 0 goes over here. The other bits slide down like that. And because this had 4 bits, it needs to continue to have 4 bits. So we just fill in the empty space with a 0. So we're left with this. And now we can continue checking. And we can do that until the whole thing is 0 or we reach the end of the number. So to recap, we are going to first use the bitwise AND to check for 1s. And then 2, we're going to use the shift bits to the right operator to iterate through all bits. And then we're just going to keep track of a count the entire time of how many 1s that we see. And I think that's it. So let's jump into the code and see if we can get this to work. So the first thing I'm going to do is set up that count. So I'll just set that equal to 0. And now we need to iterate over the number that we're given, which is n. And we know from the problem that the input must be a binary string of length 32. So I can say for I in, what I'll say is for bit in range 32, because we know we have to iterate exactly 32 times, we can do this to check each bit. And then what we want to do first is say, and this is the first part, the AND. So if actually, we don't need to use this bit thing. I can just say for I in range 32, because I don't even think I need that. Because all we need to say is, remember, I'm not iterating over the bits in this case. That would be one easy way to do it, but I'm using the bit manipulation operations. So what I can say is, if n, here's where we use the bitwise AND. So if we take the whole number n, if n and 1, if that is true, so I could say equals true, but I'm just not going to include that because this means the same thing. If we take the full number and 1, what that is going to tell us, and I'll write it over here, is the rightmost bit a 1. That's what we're checking there. If that is true, we want to say count plus equals 1. We want to increase the count by 1 because we saw a 1. Now we need to iterate by shifting all the bits to the right. So on the next iteration of the for loop, we're checking the next bit, and the one that we just checked gets removed off the end. So we can do that by saying n equals n, and this is the right shift by 1, like that. And remember, this is saying that shift all bits to the right by 1. And then at the end, we just need to return the count, like so. So let's run that, see what we get. Wonderful. So that appears to be working for the 3 test cases. So I'll go ahead and submit it. Perfect. So that appears to be about as quick as you can do it. And again, I really think the bit problems are interesting. So even if they don't come up in a lot of programming interviews, I think it's good to learn because it might serve you well at some point in your programming journey. Thanks so much, everyone.